When a chemical reaction takes place, reactants come into contact with one another, bonds between reactant atoms are broken, and new bonds are formed to make products. Now, in order for this to happen, certain conditions must be met, and these conditions are collectively known as the collision theory of chemical reactions. For reactant particles to undergo a chemical reaction, they first of all have to collide. Now, this might seem a little bit obvious, but there we have it. And not only must they collide, these collisions must be what is known as effective collisions. And the following two conditions make a collision effective. The reacting particles must be correctly orientated towards each other. In other words, they have to approach one another from the right direction. And thirdly, when they collide, they have to collide with sufficient kinetic energy for their valence orbitals to overlap. And this minimum threshold energy with which they must collide is known as activation energy, which can be abbreviated to EA. If we look at a typical chemical reaction, a molecule of hydrogen gas reacts with a molecule of iodine gas to form two molecules of hydrogen iodide gas in a reversible reaction. Now, what I'm going to do is draw a little magic spectacle diagram of what is happening at the molecular level. So if we have the hydrogen molecule, which is two small hydrogen atoms, which are joined by a covalent bond, and they are going to react with two larger iodine atoms, also joined by a covalent bond, and these are known as reactants. We assume they have collided with the correct orientation and they have collided with sufficient kinetic energy, which is activation energy. Now, before they make products, there's an important stage that I'm going to show you over here with square brackets. Now, I put it in square brackets because this is a stage between the reactants and the products. Let's redraw the reactants, the hydrogens, and the iodines. Now, during this stage, the covalent bonds between the hydrogen atoms and between the iodine atoms start to break. And shortly thereafter, new bonds start to form between the one hydrogen atom and the one iodine atom and the other hydrogen atom and the other iodine atom. So new bonds are forming. Old bonds are breaking and new bonds are forming. Now this stage or mechanism between the reactants and the products is known as the activated complex. And it is a very high energy and a very unstable mechanism, because they are no longer reactants anymore and they are not quite yet products. It's high energy, it's unstable, it's an intermediate between reactants and product where old bonds are breaking and new bonds are forming. We now have two new molecules formed with new bonds between the hydrogen atoms and the iodine atoms to form two molecules of hydrogen iodide, and these are known now as products. Remember, the energy has dropped quite significantly from the activated complex because bonding is a process where energy is given out. It's an exothermic process. Although we have exo and endothermic reactions, bonding itself is an exothermic process which gives out energy. So we started out with reactants, which collided effectively. We then reached a high energy intermediate called the activated complex. Then we finished with products, which are in a low energy and stable state now. Number 1, reacting particles have to collide with one another. Now this might seem a little bit obvious, but there we have it. And not only do they have to collide, but these collisions have to be effective collisions. Now what makes an effective collision are the following 2 points. First of all, the reacting particles must be correctly orientated. In other words, they have to approach each other from the correct direction. And number 3, when they collide, they have to collide with sufficient kinetic energy for their valence orbitals to overlap. And this minimum threshold energy with which they must collide is known as activation energy, which can be abbreviated to EA.